Okay, so section 9.5. So we're going to talk today about logarithmic functions. So today we're just going to define what logarithms are, use them a little bit, and then we'll do all of our properties of logarithms on, or when we get back from Thanksgiving. So next Monday. Before we get into what a logarithm is, we're going to start out by looking at, I'm going to say, let's look at f of x equals 2 to the x. So we're going to say, let's look at, say, f of x equals 2 to the x. So I'm going to look at its graph, and then we're going to look at the graph of its inverse. We're going to talk about what does the graph look like, what would the inverse look like. So this is what we did last time, the time before. So I'm going to say x, y equals 2 to the x. And then I'm just going to choose some numbers to plug in for x. So we go -2, -1, 0, 1, and 2. Something like that. This is all stuff we did last time. So I'm going to say, let's go 2 to the... If I go 2 to the -2, that's going to give me a fourth. I'd have a half, 1, 2, 4. If I wanted to go one more, I can go up to 8. What did I wrote, that should be, is that what you're saying, the fifth? Yeah. There we go. I have no idea why that 5 was there instead of a 2. Okay, so this is all stuff we did last time. If I wanted to graph it, I'd say, okay, here's my graph. -2, a fourth, and then a half, 1, 2, 4, 8. So I just plotting points, seeing what my graph looks like. There we go. Okay. What if I wanted to look at the inverse? So we've got this right here, plot points, put it on the graph. What if I want to look at the inverse? What am I going to do? What's the relationship between a function and its inverse? Yeah. So what do I do with my x's and my y's if we're looking at an inverse? How are the x and the y's? So I'm just going to switch them. So I'm going to say, let's go. I'm going to have 1/4, 1/2, 1, 2, 4, 8. Those are going to go with my -2, -1, 0, 1, 2, 3. So I have that. Plot my points. My graph looks like this. So I can say, okay, the inverse of 2 to the x, I can draw a graph. We just switch x and y. So I'm just doing things, same kind of thing we did last time, or 2 times ago. So now if I want to know the equation of the inverse, I could go through, do what we did with when we did inverses before. So if I want to find the inverse, of f of x equals 2 to the x. So I want to know the inverse of this function. So I'm going to go through, do the same process that we did before. I'm going to say, let's replace the f of x with a y. So y equals 2 to the x. What would I do next? Flip x and y. So I have x equals 2 to the y. And now at this point, we're going to get stuck.
So this kid, he says it's 19 minutes left on this test, but we're trying to take this test up here. And it says when we click on it, to end test early, but I can't find that over there on this one. Do you know how? It's that one right there.
Right here. I think you'd have to have just an answer for all of them. So if we just go and like
No, I
just
put that in and it didn't even take the bad answer that I tried to put in.
Next, I feel like you'd have to have some sort of answer on those ones.
I'll just try and throw something in. Thank you.
Okay.
Thought maybe I was looking
Yeah.
to see where the end result was. I was trying to finish it.
Or you could probably even go on your end and just like put like if you think you score them, then it might let him finish. I don't know. Okay. Anyways, so if we get right here, x equals 2 to the y, like knowing, so we're, for this class, we're pretending we haven't taken any other math classes. Like this is our first time we're learning things. At this point, there's nothing that we can really do. We get stuck at this point. So this is where logarithms come into play. So we're going to write out the definition of a logarithm. So logarithm. So I'm going to say if b is greater than 0 and b is not equal to 1. So these are the same requirements we had for exponential functions last time. I'm going to say then y equals log base b of x means x equals b to the y. So this is a way that, so if I have x equals b to the y, if I'm trying to solve for y, it's going to be a logarithm. I'm going to add, so I've got y equals log base b of x means x equals b to the y. I'm going to say for every x greater than 0. So we're saying that my domain is x has to be bigger than 0, which makes sense because will an exponential function ever give you a negative output? No. So x is greater than 0. I'm going to say, and every real number y. So this is the definition of a logarithm. So it's kind of a scary name, at least initially. But it's just a way that we can deal with solving if I have an exponent, or if my variable is an exponent. Can I have you close the door, Kayla?
But she's so dumb.
Okay. So we're gonna just go through, do some practice of just evaluating some logarithms. And yeah, so we'll go through and do this. So the first example that we're going to look at is, so we want to write as, for each of these, we're going to write as an exponential equation. So I want to write each of these logarithmic equations as an exponent. And then we'll go the other way as well. So the first one, I'm telling you that log base 3 of 81 equals 4. So the way that I think through these, so if we're saying y equals log base b of x, if you start with your base, so I say, well, let's go your base. Let's work the long way around to the x. That gives me b to the y equals x. Or if I start with the base on the exponential, start with your base, work your long way around to the y. So if I have log base 3 of 81 equals 4, I'm going to start at the 3, long way around to the 81. This is the same thing as 3 to the 4 equals 81. Is that true? If I go 3 to the 4, is that equal to 81? Yes. So if I wasn't sure, if I had said, tried, well, 3 to the 81 equals 4, is that equation right? No, if I had tried 4 to the 3 equals 81, that doesn't work. So that's the only one. So this, we call it the base of the logarithm. So this is log base 3 of 81. So the 3 is the base of the logarithm. The 3 is the base of the exponent. So we use the same word on purpose. Any questions on A? Okay. We'll do maybe just one more here. I'm going to look at C. So for C, I'm saying log base 7 of the square root of 7 equals 1/2. I'm going to do the same thing. Let's start with a 7. Work my way around to the square root of 7. I have 7 to the 1/2 equals the square root of 7. Is that true? If I have a fraction, if I have an exponent of 1/2, is that the same thing as doing the square root? Yes. So when we're doing these ones, if I want to make sure that my answer's right, like if we're going log to exponent, make sure your exponent makes sense. Okay. Let's do just a couple where I'm giving a log equation. So for these next ones, I'm going to say we want to write as a log equation. Okay. So if I give you something like, I'm going to do C, so I'm doing number 2. This is in your book, that's why I'm starting with C. If I say, let's go 5 to the negative 3 equals 1 over 25, or 1 over 125. So when I write my equation, I'm going to start at the base, work my way around. This would be the same thing as saying log base 5 of 1 over 125 equals negative 3. So the answer to the log equation should always be the exponent of the exponential equation. So the answer to a log is the exponent. Any questions on C? Okay. The last one I'm going to do from this section, I'm going to do D. This says pi to the 7 is equal to Z. So I just have this equation, pi to the 7 equals Z. So we've got a pi here, we've got a variable. We can still do this the exact same way. So I'm going to start with the pi, work my way around to the 7. This is log base pi of Z equals 7. Okay. Can this Z here be any number we want it to be? No. What kind of numbers can Z be? Can it be a negative number?
No.
Can it be 0?
No.
No. So it can only be a positive number. Okay. So we're going to go through, we're going to evaluate a couple logarithms. We're going to solve some simple equations with logarithms. And then we're going to look at some graphs of logarithms. Okay. So if I give it, so now, let me start my sentence over. Words are hard. So we want to find the value of each of these logarithms. I'm going to say evaluate each of these. So if I am saying we've got, let's do log base 3 of 9. What is this equation really asking me to find? If I say log base 3 of 9, what do I want to know?
1 squared.
So, yeah, so it's going to be, it is going to be 2 because 3 squared equals 9. So I'm trying to say what exponent do I put on a 3 to get a 9? Which is going to be a 2. Or like the book says, it's equal to 2 because 3 squared equals 9. So we're trying to figure out what exponent goes on the base to get my input. I think we just call it an argument with logarithms. Okay, any questions on A? Okay, let's look at B. If I give you something like log base 2 of 1/8. So I'm going to do the same thing. I'm going to say, well, or if I set that equal to x, this is asking me what exponent do I put on a 2 to get 1/8. What do you guys think here? So it's going to be -3. So I have that 2 to the -3 is 1 over 2 cubed. So my x here is going to be -3. Okay. Questions on A and B? Okay. So now if I look at, we're just going to do one more of these. So for C, I'm now saying log base 49 of 7. So that's the last one we're going to look at from this section. Log base 49 of 7. So for this, I want to know what exponent do I put on an x to get a 7? Okay, it's going to be 1/2. Where are you getting, how do we get 1/2?
1/2 is just square root.
Yeah, it's just a square root. So remember that we have the square root of y is y to the 1/2. So if I go 49 to the 1/2, that's equal to the square root of 49, which is 7. So x equals 1/2. Okay. We could have also done this the same way we did our equations last year, or not last year, last time, where I could have said, well, 49 is 7 squared, so I can say this is 7 squared to the x equals 7, 7 to the 2, x equals 7 to the 1, which means 2x equals 1, or x equals 1/2. So either way works, using what we know about square roots and their exponents, or do this the same way we solved exponential equations on Thursday. Any questions about evaluating some simple logarithms? Okay. So we're going to look at some simple equations that are dealing with logarithms. We'll get into more complicated equations it'll be next Wednesday when we get back. We'll look at some more complicated equations. But for now, the equations that I'm going to give you are going to be something like, so we're going to solve for x on each of these. So the first one is log base 5 of 1/25 equals x. So this is the same kind of thing we just were doing. So I'm going to put this into my exponential form. So I'm going to say this is asking me 5 to the x equals 1/25. What would x have to be to go from, Sarah? Say that again. -1/2, is what you said? Okay, so if they were switched, then I would say yes, it's -1/2. But it's going to be x equals -2, because if I go 5 to the -2 is 1 over 5 squared. And so x equals -2. So not bad so far. Okay. Next one. Let's look at log base x of 8 equals 3. So for this one, I now have my x as my base. So this is x to the 3rd equals 8. What does that mean x is equal to?
2.
X equals 2. So we need to double check. My base can't be negative, and it can't be equal to 1. So we're good there. It's not negative. It's not 1. and it can't be 0. So it has to be positive, and it can't be equal to 1. Okay. Questions about B? Okay. Next one we're going to look at, I can say, let's go log base 6 of x equals 2. So once again, I'm going to put this into my exponential form. So I have 6 squared equals x. So this one's simple. X is 36. We don't even have to hardly think about that one. Okay. Next one, I have log base 13 of 1 equals x. So if I put this in exponential form, I'm saying 13 to some exponent equals 1. What is my answer always going to be for my exponent if I get a 1 here? 0. So x equals 0. And then last one. So we're solving for x. So keep that in mind here. I'm saying log base h of 1 is equal to x.
Is that an H?
That's an h there. So this is me pretty much the same thing as the last one. So remember your h. So this has to be non-negative. It has to be positive, and it can't be equal to 0. This is really the exact same thing as what we just did.
It could be any number higher than 1.
So it could be a fraction. It could be a half. It could be something between 0 and 1. It could be any number bigger than 1. But the same kind of thing as d, x equals 0. And that should be an e, not a d. But that's fine. Okay. So this right here is one of my properties of logarithms. If I have an input of 1, what will my answer always be? 0. We've got a couple of other properties as well. So let's write down some properties of logarithms. So these are just some simple ones. We're going to talk about our quotient rule and our product rule and our power rules next time, if you guys remember those from last year, from Sec 3. Okay. So we're going to say, when we're doing this, I'm going to say let B be a real number with B greater than 0 and B is not equal to 1. If these things are true, so if B is real, so we're not dealing with imaginary numbers. B is bigger than 0, so B is a positive number that is not 1. Then I have the following 3 properties. The first one, this one we've already talked about. If I go log base B of 1, what will this always be equal to? 0. Okay. The next one, I'm going to say if I go log base B of B to the x, what would this be equal to?
X.
That's just going to be equal to x. Why is that equal to x? So if I try and rewrite this, that's saying b to something equals b to the x. The exponents are going to be the same there. And then my last one, this says if I go b to the log base b of x, this right here is also equal to x. So number 2, that one's not too difficult to see why it's x. If I look at this one right here, so we want to know what this is equal to. You don't necessarily, so you don't need to write down what I'm writing down here. I'm gonna erase it. But if I say, well, we want to know what is b to the log base b of x, so that's equal to y. I'm gonna put this in my log form. So if I convert this into logarithmic form, start with my b, work my way around, this is the same thing as saying log base b of y equals log base b of x, which means the y and the x are going to be the same. So if we have the same base, if we either plug an exponent into a log or a log in for the exponent where we've got the same base, it's like they're canceling each other out. So really what I'm saying is I'm saying that these are inverses of each other. So I'm doing the composition of two inverses. If you do the composition of two inverses, what are you going to always get? You're going to always get x. Okay, so these are my properties of logarithms. We can use these to evaluate some quick logarithms. So if I give you something like, we're on number 5 here. I'm going to say if I have log base 3 of 3 squared, what is that going to be equal to? It's going to be equal to 2. Okay. What if I give you log base 7 of 7 to the negative 1? What would that be equal to? It's equal to negative 1. What if I wanted you to do 5 to the log base 5 of 3? What is that going to be equal to? It's going to be a 3 because my bases here are the same. And then finally, if I gave you, those are both 5s right there. For some reason, over like lately writing 5s, I struggle. Like I don't like how my 5s look when I write them anymore. A hard time writing 5s. This last one, 2 to the log base 2 of 6. What would this be equal to?
6.
It's going to be equal to 6. So if your bases are the same, they are inverses, which means they're going to. So it's like I'm taking, if I have 5 to the x and y equals log 5x, or I guess I should say like f of x, and that's my inverse. I'm plugging my inverse in for x, doing my composition. They end up canceling out, or they end up giving you an x. Okay. So let's go back to where we were at the beginning. Where we were trying to do the inverse of 2 to the x. So I want to find the inverse of f of x equals 2 to the x. So we had started this. We had said, okay, this is y equals 2 to the x. We switched x and y. So this is where we left off. If I want to solve for y, what is y equal to? Based on what we've been doing so far, what would y be equal to? So I want to get y by itself. This is going to be log base 2 of x. So I'm going to put this into my logarithmic form. Start at the 2, go around, log base 2 of x equals y. And so if I write this in my function notation, my inverse function of f of x is log base 2 of x. That is the inverse of 2 to the x. Okay. Any questions on getting that inverse? Okay. So if I want to, so we're looking at logarithmic functions. Logarithmic functions look like this. So if we have, let's look at this. So if I look at the domain of exponential, so let's compare exponential and logarithmic. So if I said, okay, if I have f of x equals 2 to the x, what is the domain of this function? If I have 2 to the x, what is my domain? So
No, 1, 2.
So we're going 2 to the x. We can plug any number you want in for x. We're all good. So my domain is negative infinity to infinity. What about my range? If I think about my outputs,
1, 2.
am I going to get negative numbers out?
No.
Am I going to get a 0 out? No, but can I get like 0.5?
Yeah.
Yes. So this is going to be 0 to infinity. So that's for f of x equals 2 to the x. What if I want to look at its inverse? So my inverse of that is log base 2 of x. How are the domain and range of the inverse? How does the domain and range of the inverse relate to the original function?
They're flipped.
They're flipped. So my range is going to be the domain. My domain is going to be the range. So the domain of a log is 0 to infinity. So we've talked about this. We can only plug in positive numbers to a log. We can't plug 0 in. We can't do negative. But my range, we can get any number out that we want. We can find an x value that will give me any y value out. Okay. Any questions on that? So yeah, so this doesn't matter. So in this right here, I put 2 to the x. I could actually, instead of writing a 2, I can say this is b. So this is going to be the same. Doesn't matter what your b is, as long as it fits with all of my exponential function rules for b and all of my logarithmic function rules for b. This will always work. So for any base for a logarithm, this is always going to be my domain and range, just like for any base for an exponential, that is always my domain and range. Okay. So we're going to go over doing a couple of graphs, and then that's basically it. So we should have 2 more problems that we're going to go over, and then you'll have the rest of class to work. Next time we are going to look at properties of logarithms, and we'll talk about common logs, natural logs, change of base, all that good stuff that once upon a time you know. Okay. Actually, I'm going to do this on no, I've got space. I can do it right here. So if I want to graph, let's do f of x equals, actually I'm going to write it as y equals because that's how the book is doing it. So let's say y equals log base 3 of x. I want to graph that. So this is a little bit more difficult to just say, well, let's just plug any number we want in for x. It's not always going to give me a nice integer output. So what I'm going to do first is I'm going to say, well, let's look at x. Let's write this in exponential form. This is going to be x equals 3 to the y. So these two are the exact same thing. So now we can choose any number we want for y, and then my x is going to be based on that. So if I make my chart like we've done before, so I'm going to say, okay, x. In this case, my x is 3 to the y, and then for my y, that's going to be my log base 3 of x. So we're going to choose numbers Actually, I'm just going to say that's, yeah, so y equals log base 3 of x. So I can choose my numbers for my y. So because I know that x is 3 to the y. So in this case, I'm going to say, well, let's go my -2, -1, 0, 1, 2. I really like plugging those numbers in. So if I'm saying, okay, y equals -2, what is x going to be equal to? So this is going to be 3 to the -2, which is 1/9. Or if I'm going y equals -1, x is 3 to the -1, which is 1/3. X equals, or y equals 0, x is 3 to the 0, which is 1. Y equals 1. I have x equals 3 to the 1, which is 3. Y equals 2. X equals 3 squared, which is 9. So if we're graphing a log, you're going to choose the numbers for your y and then go figure out your x's. So we don't want to just plug any random number in for x, or because it may not work out nice, but we can plug whatever we want in for y and then we can figure out my x. So if I want to graph it, I have x equals 1/9 is -2, x equals 1/3 is y equals -1, x equals 1, y equals 0, x equals 3, y equals 1, x equals 9, y equals 2. So there's that graph. We could check it if I graph 3 to the x. It is that inverse. It is reflected across that line y equals x. So we're all good there. Any questions about that? Okay, so we're going to do one more example and then we will be done. Okay. So for this last one, I want to graph. There's that if you still need that. I'm going to say, let's look at y equals log base 1/2 of x. Okay. Yeah, so when we graph it, I'm going to say this is the same thing as saying x, or 1/2 to the y is equal to x. So we're going to always choose, I like to go -2 to 2 for my y values here. So say, let's make my chart. So my x values are equal to 1/2 to the y. And my y is, it's the log base 2, or log base 1/2 of x. So I'm going to choose my numbers for my y. So I'm going to say, let's go my same -2, -1, 0, 1, 2. Okay. And now I'm going to say, well, for my x's, this should be 1/2 to the -2, which is 4. If I go 1/2 to the -1, that's where we're going to get the 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4. So now we can graph these. So when I plot my points, I have x equals 4, y equals -2. X equals 2, y equals -1. X equals 1, y equals 0. X equals a half, y equals 1. A quarter, y equals 2. There is that graph. Okay. Are these graphs, so is a logarithmic function one-to-one? Are these functions one-to-one? Yes. So they've passed your horizontal line test. They are one-to-one. What do we notice about the x-intercept on both of these graphs? We had different bases. This was a half. That's a third.
It's 1.
It's always gonna be a 1. Do we have a y-intercept? No. Anything else you want to say about this? My domain and range, we already talked about those. Anyway, so if it's a number, if my base is between 0 and 1, my graph is going to go like this. If my base is bigger than 1, my graph is going to go like that. So the graphs that you're going to do are going to be simple. We don't have any shifts left or right, up or down. So it's going to be shouldn't be too bad.